This video is brought to you by Brilliance. So I've been watching a lot of RedBull videos recently. They're all super amazing and fun, but the one video that spoke to my soul is this one. In case you clicked on this video and are somehow blind, it's a video of a guy flying a plane through a tunnel. It's a pretty cool video altogether, but it got me thinking about the game I was working on a couple months ago. And funny enough, I was actually working on making the plane in that game fly through a tunnel. Well, more appropriately, making it do that without smacking the surface of the wall every single time. The reason why it's so hard to fly in a tunnel has everything to do with the control scheme. You see, the control scheme was ripped directly from the Game Jam version of the game, which I made like 3 years ago for the Godot Wild Jam. For the Jam version, I went with mouse controls because my smooth brain finds WASD incredibly confusing for dogfight games. In the Jam version, the plane always points towards the cursor, and the speed is determined by how far the cursor is from the plane. And that provided all the agility that the plane needed to dodge enemy planes and fly around in an open sky, which is basically what the Jam version was about. If you want to get a feel for the controls, then you can try it out here. After the video, of course. See, for the main game, I wanted to give the player the ability to step out of the plane and move around an open world. So I wanted stuff like sky bases and tunnels, kind of like Rain World. I know it sounds like a mess, but just let me cook, okay? This came with a new set of challenges that needed to be solved. And man, were they challenging. The Jam version was not made with obstacle avoidance in mind. What I needed was a way to maintain the fluid controls of the plane when it's in an empty sky, and for the plane to kind of lock in for all those tight squeezes. But how? Well, the answer to that lies in this overly elaborate obstacle course that I spent way too much time on. I made it to kind of showcase whatever idea I come up with to solve this tunnel navigation problem. Let me break this problem down into 3 different stages. The entry, the survival, which is what I'm calling the actual tunnel navigation, and the exit, S, ease. Anyways, the main cause of crashes in this first stage becomes super obvious when we draw a line between the cursor and the plane. We can see that whenever an obstacle intersects this line, the plane tends to crash into said obstacle. A quick fix for that would be to make the cursor a physics collider, which should prevent it from phasing through walls or pointing directly into obstacles. But this doesn't always work because there are still times when the plane lags behind just enough to still get caught by a wall. For special cases like that, I'll need to do something a bit more complicated. I should probably implement some kind of like object avoidance / pathfinding, like A-star pathfinding. Now Godot actually happens to have its own A-star pathfinding implementation, which can be used to create paths in 3D, but I won't be using that because Godot, as far as I know, you can only really define an obstacle that is on the ground, as in the X and Z plane, and not the X and Y plane. I tried tweaking this by rotating it along the x-axis, but nothing. Either I'm too stupid or this just doesn't work for my case. So I have to do it my own way. Basically, I made the cursor detect when it has touched an obstacle. Then when it does so, it leaves a point at that specific moment. Then the plane will first need to fly towards that point before continuing its journey to the cursor. In practice, this looks really good, and in hindsight, it probably works better than A-star pathfinding for this use case. For smoother movement in the survival stage, because right now it still kind of looks jank, I'll be expanding on the idea from the entry stage by basically just asking the cursor to place even more points as long as it's still in contact with obstacles. And that results in something like this. Now, if you're wondering how the plane is even following the path to begin with, this actually took forever to put together, but here's kind of like the breakdown. So let's take a path like this, for instance. Basically, each path is divided into these line segments. Now at the start of the path, the plane faces in the direction of its current line segment. Then as it travels along that line segment, it slowly begins to look towards the end of the next line segment. Now there's a little force that pushes the plane towards whatever line segment it's currently on. And then after everything, it just repeats this till it reaches the end of the path. Now before I show you a comparison, I just want to take a moment to shout out today's sponsor, Brilliant. Brilliant is an interactive learning app that helps you really understand math, science, data analysis, and more. And not just memorizing formulas. Their hands-on lesson walks you through concepts step by step, letting you learn by doing, which studies show is more effective. What I love most is that it's built by experts from places like MIT, Caltech, Microsoft, and Google. And it actually makes learning feel fun. You get helpful feedback, just the right amount of challenge, and you can use it at any time on any device, whether you're at home or on the move. If you're looking to level up your skills or just want to learn something new in a smart way, check out Brilliant. Use the link in my description to try it for free for 30 days and get 20% off their premium annual subscription. Let's finally get into this comparison. It's still a work in progress and I'm actively trying to make it look and feel even better, so stay tuned for that.